All right, Joel, you can help me with the next one then. All right.
Okay, so you want to write it with your fancy integral signs.
All right.
Just to wow the kids.
Yeah. Sure.
Between 0 and half.
Great. Yeah.
And you've got your 3y to the power of 4
Yep.
5 dy.
Yep. 5 dy, and make sure you're putting brackets here as well. And then let's actually integrate this. So what are we going to get? We're going to get y to the 5.
3y on the 5 over 5
Yep.
plus 5y.
Great. And then half to 0.
Substitute.
Yeah, with the substitution, like it's pretty tedious to do it for all these different examples. In an exam, though, I strongly recommend you do it because, like, in the case you do a substitution error or something like that, you can at least get some marks for that. So let's put that in.
Hey, are you doing a test? Oh, how was that? Was that fun? Yeah. Easy though. That is a yes.
Yeah.
Easy though.
Joel, you got an answer for me?
Yes.
Oh yeah, Joe, you got an
I
answer.
hope I put it in right.
Yeah.
So I got 403 over 160.
I did not get that.
Yeah, no.
I got that.
245 over 96.
I got 403 over 150.
Oh, okay, I'll get one. Dang.
Well done.
I'm just going to change it to not.
Oh, 400.
403 over 160.
150.
50, sorry. Yeah.
Is it 160? Actually, I got 160. I got 160, sorry.
It was 150. 60, I got 60. And
He wrote 50. I trust her.
Don't, never trust me. Never trust me. Okay.
I
Now,
just gotta go along with it.
Now this
With-
one's a bit funky.
yeah, why is this funky, Harry? I love funky questions. They make us think a little bit, right? Just a little bit. Okay, so what did we always need for, now bounded by the y-axis, what do we actually need to have? X as the subject, right, in terms of y. So that's probably one of the biggest mistakes when students start off integrating. Like they're not too sure about which one's which, okay? So it's all, like, whichever axis you're bounded by is always corresponding to this dy or dx, okay? So that's the way you can remember it. And so you need this in terms of y. What are you thinking, Matt?
It has to be plus minus.
Okay, so we need x as a subject, just like we had in all these ones. The issue becomes, okay, if I try to do that here, if I take the square root of both sides, I actually have to take two cases, the positive and negative cases. So now there's a way to get around this in terms of the actual integration. Because like, how do you integrate something that's a positive and negative case? Well, what we do is we think about what this graph actually looks like. What does y equals to x squared actually look like? It is a parab, right? It's a parab that looks like this.
Oh, so it's just gotta take the positive one?
Well, think about it, right? How is there a positive and negative in this? They're all above the x-axis.
The other side.
Right, but remember, this is in terms of x. So x actually has positive and negative values. So the negative component, and you can test in values to check, right? The negative side will be here. Because if you put, for example, you know, when y is equal to, hang on. If x is equal to 1, for example, right, you'd have positive 1 over here, and you'd have positive 1 for the x and y coordinates. But if you have a negative x value over here, then y must be equal to 1 over here. So that's where your negative component comes in. That's why you have two graphs here. Positive square root of y and the negative square root of y. Which one do we want? Well, it doesn't actually matter in this situation yet because it's an even function. So if I'm saying it's bounded by the axis 3 to 5, and usually they'll give you a graph with this. So if they're asking for the area, they'd give you a graph that looks like this. Yeah. So in that case, you would take the positive side. In this particular situation, it won't matter because they're even functions, right? So let's take the positive case.
Never lost the test. Excuse me.
Now, yeah, so I think the question is probably phrased a bit ambiguously. So if they give you the diagram, it becomes a lot clearer, right? So on the positive side. So let's take that. So we'll take x is equal to the square root of y. Eva, what are you thinking next?
And then you just put y.
Yeah, let's do it. So we're going to integrate now from our bounds 3 to 5 and the square root of y. Callum, you want to take over?
Change the square root y to the power of 1.
Exactly. Yeah, exactly right. So anytime you have radicals, always change into index form when you're trying to integrate or differentiate. It's going to become a lot easier. Sorry? What's up? Okay.
We
So,
have decimal.
so we get y to the half dy. We can't even write it as a fraction. Let's have a look. So now remember, you're still adding 1 to this power, right? So that's still going to become 3 on 2. But then what are you putting on the denominator? You're putting that new power on the denominator. When you have a fraction, what does that become essentially?
Just fraction to the point that you get.
Yeah, that's one. So if you were to do it extended, right, you'd be dividing this by 3 on 2. That's essentially the same thing as multiplying by the reciprocal. Or, according to Matt, you multiply by 2 on 3, still with the same bounds. Can you put that in for me? Yeah, it's about 3.98 something.
Do you want to see a picture of Madison?
We'll round this off. 2 decimal places, maybe?
Yeah.
What do we get?
399.
399 units squared,
Ooh, fancy.
approximately.
And evolve